Welcome, everyone. We're straight up 4 o'clock. It looks like we are getting everyone on. We're expecting here at the beginning. I'll ask that our team here, the IT team behind the scenes making all this work, if you think anyone's missing at this point, to give me a heads up. But I see all 5 of our judges and President Satterley. And a few of our students coming on. We're getting there. Well, I think I'm going to go ahead and get started unless someone gives me the fire alarm not to start yet. But I just want to welcome everyone. This is my first time emceeing a virtual event. So luckily we have a lot of people here helping out and making sure this runs smoothly for you all. I just want to say hello. My name is Chandra Ford. I'm the Center Executive Officer for Southwest Idaho for the University of Idaho. I'm honored to be a part of this program highlighting the great work of our graduate students across the state. Thank you for joining us for what we hope is our first and only virtual 3-minute thesis event, or 3MT as we call it. This event is a friendly competition among our 3 public institutions of higher education, and it is also a platform for us to focus on the ways we all support and encourage one another. We'll take short breaks in between the presentations to share some videos highlighting our 3 institutions, and for a little bit of entertainment in between the presentations. And just a reminder, this is the 3rd annual statewide 3MT event competition, and the winners of today's competition will be able to compete at the Western Association of Graduate Schools Regional Competition, which takes place on March 24th. And it will also be held virtually and hosted by Boise State University. Please make sure to mute your microphones during this program, unless it's your student and it's your time to speak. We have no background noise, so we appreciate that. And then I just want to welcome all everyone who's participating, not just our students who put a lot of work into this, the judges, the faculty, mentors, and everyone else that's watching today and supporting our students in this process. So first and foremost, both students and attendees, please make sure your Zoom screen is set on the side-by-side speaker view for best possible viewing. You will see the view option noted in the upper right-hand corner of your screen. Choose the side-by-side speaker option. And then there's also the timer on the screen. I'll mention this one other time before we start, especially for those students. There'll be a 5, 4, 3, 2, 1. Then you take off on your presentation for your 3-minute time that you've got to share your story. But before we get started, I want to thank our judging panel. The community leaders have graciously donated their time to judge this event. And we have an amazing group of judges this year. I'm super excited. I know all of you have met you before. I'm going to start by introducing Clark Krause. And he is joining us again after serving as a judge last year. And since 2010, Clark has served as the executive director of the Boise Valley Economic Partnership. And I'm lucky enough to be on that board. I get to see firsthand all the work of Clark and his team. He leads an organization that played a key role in attracting 15 companies and over 3,400 jobs to the Boise metro area in the past 5 years. Clark came to Boise after serving as CEO of the New Mexico Partnership, and his experience has helped Idaho gain a competitive advantage in economic development. Thanks for being here, Clark. Next is Representative Carolyn Nielsen-Troy. She's a member of the Idaho House representing District 5. She's also an old friend and is currently vice chair of JFAC and serves on the Judiciary and Rules Committee. Carolyn lives on a farm in my hometown of Genesee, Idaho, in northern Idaho, and is an Idaho native and a University of Idaho graduate. She currently serves on the Idaho Rural Partnership. She currently serves on the Idaho Rural Partnership Board and is also on the board of our University of Idaho Cooperative Extension, which serves all of the counties in the state of Idaho. She also is serving on the James A. McClure Center Board, and I think many of you know what that group does around public policy in our state. Outside of the legislature, she runs a nonprofit consulting firm called Nielsen Advisory Group, and I'm really happy to have Carolyn here. Thanks for doing this. Next, we have Andy Scoggin. He is currently a member of the State Board of Education and therefore spends an enormous amount of time leading our state's educational ecosystem from K through 12 and higher education. Andy is also a retired executive from Albertsons Corporate. I first knew Andy is an Executive Vice President for Human Resources, Labor, Public Relations, and Governmental Affairs. If you can imagine, he supervised all of those entities at Albertson Corporate. He is a leader with many talents in his career, helping bring back and grow the Albertsons LLC from a $4 billion annual sales enterprise to the second largest nationwide grocery store chain with over $63 billion in sales, made him a partner in one of Boise's great business success stories. And I might say comeback success stories. He's now a general partner with Stage.O Venture Capital, which seeks to invest in Idaho companies, and serves on the board of a number of community organizations, including Idaho First Bank, St. Luke's Health, and the Interfaith Sanctuary Homeless Shelter. Thanks, Andy, for being here. Matt Weaver is our fourth one. He is the Deputy Director of the Idaho Department of Water Resources, and it happens to be my neighbor here in the Idaho Water Center, a few floors up, his office is. He oversees the department's hydrology section, Water Compliance Bureau, and Information Technology Services Bureau. Matt is a Montana native and earned his bachelor's in civil engineering from Montana State and a master's in hydrology from Boise State. Matt, his wife, and his twin boys love living the Idaho dream, and they spend time skiing, backpacking, mountain biking, and fly fishing. All right, last but not least, Enrique Rivera. He's our fifth judge, and this is his second time doing it as well. So thanks for trying it again, Enrique. He was recently named the president and CEO of the Idaho Hispanic Chamber of Commerce. He also served as with the same group. He served on their board of directors before they named him president and CEO. It is the leading Hispanic business networking, advocacy, and development organization in the Treasure Valley. And he has been a key figure in bringing together influential Hispanics to connect, collaborate, and create new opportunities. He has also served as the president of the Community Council of Idaho. He's a vice president and commercial loan officer for the Bank of Idaho. So he has a lot of roles in our community. And last but not least, I'd just like to mention that he served on the City of Nampa's Hispanic Latino COVID Task Force as a leader in helping address the many local challenges around the pandemic. Thanks for being here, Enrique. All right, now that we've introduced our set of esteemed judges, we'll move on to if you would like to see the whole event program, you can see it electronically. Just note in this slide, go to that spot on the website and you can pull it up and follow along. And before we get going, I want to give a special shout out to our graduate college deans. Adam Bradford, who's the graduate dean of Idaho State University. Jerry McMurtry, who is the dean of the University of Idaho Graduate School. And Tammy Vakahase, who is the dean of Boise State University's Graduate School. And at the end of this, Dr. McMurtry will share a few remarks. He's been the heart and soul of this event for the last 3 years, and we appreciate everything he's put into it from our side of the house. And finally, I want to recognize the university presidents from all three institutions. My boss, President Scott Green from the University of Idaho, President Marlene Tromp from Boise State University, and Kevin Satterley from Idaho State University. So the first two presidents have pre-recorded messages for us to hear. And luckily we have President Satterley here in person, and I really appreciate him being here today. So he will be our final presenter after we watch the videos from Scott Green and Marlene Tromp.
Hello, I'm Scott Green, president of the University of Idaho. Competition prepares us to be the best we can be, and collaboration and teamwork make us better at our craft. Our shared discoveries power innovation and create opportunities that benefit our state, nation, and the world. That's what makes the statewide 3-minute thesis competition so exciting. As researchers, you have devoted years to your projects, making improvement and updates while continuing your valuable work. Today, the fruits of your labor will be shared with a wider audience. The University of Idaho is proud to serve as host for this third statewide 3-minute thesis competition, the first to be conducted virtually. This competition gets to the heart of what our institutions are about: student research that has an impact for this state. In addition to our master and doctoral students at the University of Idaho, half to 2/3 of our students conduct research as undergraduates, and the University of Idaho carried out over $113 million in research last year. This research benefits our forests, streams, fields, and technical infrastructure. We also encourage collaboration among our faculty at the universities represented here today. The University of Idaho, Boise State University, and Idaho State University are already working together on projects to advance biomedical health and protect our digital infrastructure. Research also helps our institutions leverage state resources to obtain grants and contracts. Return on that investment is seen in an improved standard of living and innovation in key sectors of the GEM state economy. We have an impact, not just by doing the research, but by explaining that research in a plain-spoken way. Condensing a years-long project into a 3-minute elevator pitch sounds like a difficult task, but it's an important way to attract industry partners and policymakers whose decisions can help advance our discoveries. Our 4 University of Idaho competitors today have done just that. They're researching and developing a vaccine that can be integrated into food for fish, which can prevent disease and reduce mortality as we look to enhance our aquaculture industry. They're looking at ways to solve diseases in canola as we work to strengthen our oilseed industries. They're studying ways to treat wastewater through a new and creative discharge process that will improve water quality across Idaho, the West, and the world. And they're creating a first of its kind, comprehensive and accessible log of 16th century European hymns that can be enjoyed by a modern audience. These are 4 among the 20 master's and doctoral students who competed at our university's 3-minute thesis competition in Moscow. Their work represents a wide range of discovery that's possible at the University of Idaho and how it serves all corners of the state. It's important we recognize this great research. That's what this statewide competition is all about. Good luck to all the competitors today. I'm eager to learn about your research and the places it will lead you. Thank you.
Graduate education is so incredibly important, and not just for your future, but for the future of the whole world. It's so exciting to be a part of this event because universities don't just share knowledge, we create it. And each of you are knowledge creators, impacting the world with your new insights. You are forever a part of a university that is committed to your continued success as students and as professionals, and one that is positioned to be a difference maker for Idaho and far beyond. This event is a true highlight of the year, and I'm so excited to hear about all of the incredible work that your time and passion have created. Congratulations on being here, and I can't wait to learn more about your projects.
Hello, everybody. Thanks, Chandra, for the introduction. Thank you, and I appreciate being asked to give a few brief remarks today. I'm going to take just a minute, and I'm going to talk about 2 things, graduate student research, and then I'm going to tell you a story. Conducting research as a student is an important part of a modern university learning process. So much of learning isn't just listening or reading or passing information from one another. Much of learning is the experiential factor of helping to achieve new discoveries. By doing so, you are helping our society pursue new knowledge through that research. As some experts put it, they say, the pursuit of knowledge and discovery has always been an intrinsic human characteristic. But when new knowledge is curated and put in the right hands, it has the power to bring about high-value change to society. So many advances in our society have come from university graduate student research, things like CAT scans and the flu shot, and technologies like solar power, the internet, and the touch screens on every one of your phones. And everyday products like fluoride toothpaste, Gatorade, and the seatbelt. All those advances in our society were the result of university graduate research programs. You can pick from hundreds of parts of our society that we take for granted every day, and all those parts originated from university research as part of graduate studies involving students like you. Student research affords you the opportunity to make discoveries, advance knowledge for our society, and get the experience as part of your education that otherwise you would not have the opportunity to get. And now, today, you're going to demonstrate your skill at condensing all of that into a 3-minute expression of your concept, which leads to my story. Once I was asked, what were some of the attributes that helped you be successful in your career? And what I told people was, I think along the way, I worked really hard at trying to get better at the art of the 5-minute meeting. Meaning there might have been projects that I had been working on for months or very difficult concepts, but being able to explain those, to get to the salient points, to make sure that the why behind what I was trying to express could be done in a 5-minute meeting. Getting that was important to my career. And I've often said the art of mastering the 5-minute meeting is critical. So this challenge that you are doing today, it's a real life skill and a skill that I've used many times, only I gave myself an extra 2 minutes. So you just have to do it better than that. And I'm sure that all of you can, and that's why you're here. What you are doing to be able to convince people and condense months of work into a 5-minute or 3-minute discussion is an important life and career skill. And so I'm very glad that you are doing it today, making all of us at all of our universities proud of every one of you. I want to congratulate you all on what you're doing and say thank you. Thank you for taking such an interest in your own education and for making the most of your future. Good luck, and thank you for participating today.
Thank you, President Satterley. And I just want to make one note about how appropriate it is that you had a chance to say these remarks live today, because correct me if I'm wrong, you have a degree from all 3 institutions represented here today, correct?
Well, I have a degree from 2 of them, and I'm president of the 3rd. And so
okay, that's how it worked. I knew you had representation.
I'm invested in every one of our students, and I'm proud of every one of them.
That's great. Thank you for being here. And I just saw a note that about 70 attendees are watching, including Dr. Marlene Tromp. So welcome. Dr. Tromp, we're glad to have you a part of today's, your pre-recorded message is wonderful, but glad to have you here live. So now I'm going to talk a little bit about more of the logistics around today's event. And I said it once before, but as a reminder for any late attendees, please follow the Zoom instructions. Set your viewing to side-by-side speaker view, to best view, and pay attention to the timer. So you'll get that time off of 5, 4, 3, 2, 1 before you start your 3-minute countdown. And of course, as you know from the first round, you will be disqualified if you go over 3 minutes. So stick to that, please, so we don't have to disqualify anybody. And then we also want you to stay on just for a few minutes at the end of your presentation. So I'll ask you a few questions. It's not a quiz or anything like that, just to learn more about you. And while the judges have just a few minutes to consider your presentation. I'm going to introduce each student by stating their name and what university they are from. But on the slide, you'll be able to note the professor who has guided them through this process, their major professor, and then the title for their presentation. As far as the audience goes, please hold your questions for the very end of our program. We will have a Q&A session, so write the question down and hold it for the end. And then also make notes, because we have a People's Choice Award, and the way you participate in that is a Slido poll will be available at the end of this program so that you can weigh in and vote on your favorite. And we ask that you vote only once, just to keep it fair and not load the deck for your best friend or something like that. So I think I've covered everything we need to get started with our first student. Okay, Jessica Johnson is from Idaho State University, and she'll be our first one to start today. I wish her luck, and take it away, Jessica.
Okay. All right, so do you know what's underneath this blank slide? This slide is blank on the outside to our perspective, but it does have something underneath. And often we are so consumed with only looking at what's on the outside, but we don't have the ability or the perspective sometimes to see what is beneath it. And we definitely don't take the time to wonder. And if it's easy for us to do this with a simple PowerPoint slide, can you imagine how easy it is for us to do this with people in our everyday life? So I want you to picture this. A first-year teacher walks into her 6th grade classroom. Her students are all nervous, anxious, and unsure of what lies ahead of them. They don't really know much about each other or their teacher beyond a blank white slide. Eventually, problems start to occur. Misbehaviors are happening in the classroom. Students are gossiping about each other, being rude to one another, being rude to their teacher. And eventually this trickles into their academic performance. The students aren't turning in their homework. They're giving little effort to classroom discussions. And they indicate on a classroom survey that they experience no joy in being at school. The first-year teacher, exhausted and frustrated, approaches her principal and asks for help. The principal points her to restorative justice. Restorative justice is a philosophy that is rooted in relationships and encourages a dialogue for people to get to know one another beyond what is a simple blank white slide. This also leaves room for people to repair harm when it is done in the relationships, because relationships are at the center of solving problems. So this first-year teacher decides to take this practice into her classroom. Every morning, she conducts meetings with her students where they sit in a circle and ask each other questions and answer questions, getting to know one another beyond the blank white slide. Eventually, the students become comfortable around each other. They're problem solving together, they're completing their homework on time, their test scores are increasing, their reading levels are increasing. But more importantly, they indicate on a school climate survey that they are starting to feel comfortable and content in being in their classroom. The teacher also indicates feeling comfortable and happy in her classroom. She reports wanting to come back to work. I know that this study, while done on a small scale, could be effective on a much larger scale. And the reason that I know this is because I was that 6th grade teacher. Thank you.
Thank you, Jessica. So I think what you're telling us, it's all about relationships and the human interaction. Does that tell us a little bit more about what you were when you were teaching? What started you down this path?
Yeah, well, I think that one thing is that there's this misconception that teachers who tend to focus more on the relationship building or the social emotional, they sacrifice academics at the expense of it. And I don't think it's an either or, it's a both and. And I wanted to demonstrate that. In fact, I would say that if you don't have the relationships down, you're wasting your time on everything else because there's always going to be a disruption to deal with. And so why not, preload with the relationships to make it more preventative rather than reacting.
So were you doing these meetings every day?
Every morning, yes. And sometimes they lasted for 15 minutes and sometimes they lasted for a half hour. The students would request them. And so when your students are asking for something, you know that you're doing it right.
That's great. Well, thank you. I think you did a wonderful job and good luck. I'm glad there's teachers like you out there.
Thank you.
Okay, I think we're ready for our next presenter. So it's Sean Bonet from the University of Idaho. And I make a reminder to Sean, I didn't do this for Jessica, so that was my bad, and she finished early anyway, but to let the timer of the 5, 4, 3, 2, 1 sound off before you actually launch into your presentation. So Sean Bonet from the University of Idaho.
My wife and I had a friend who would bring us Polish chocolate when she visited her home in Central Europe. It was delightful, but the enjoyment was always limited. So when I want gorzka klasyczna, I have to go to Poland myself or have a local get it for me. It's that very idea of having something you want readily available that drove me to my thesis. Among the European music literature available to us, there's a songbook called the Huguenot Psalter. Many artists contributed to the final product, but French composer Claude Goudamel's work with it made it famous. After researching this piece, I realized a crucial tool for musicologists in this field is missing: a comprehensive, modern edition of the Psalter that easily allows for the music and text to be analyzed is lacking. A few scholars have transcribed aspects of the Psalter, but none offer an edition that best serves trained and non-trained musicians alike. That's why my thesis is about justifying what a 21st century edition of this work should look like, why it's needed, and the initial round of transcriptions. Older primary source documents can be discernible, but often changes in notation practice make it too distracting to really dig into the source. If you look at the PowerPoint, you can see just how drastic changes can be. The image on the left is a primary source from the Huguenot Psalter, and the image on the right is my 21st century rendering of the same piece. Although the details on the PowerPoint can't be discerned too closely, one is cleaner, more organized, and ready for a modern musician to understand. I'm like a musical makeover artist. A great piece of music comes to me with a look that's really off-putting, and then I make it super attractive. In this process, I don't want to set my audience up for a blind date. That's why I take care to explain the context in which this work was produced and show my knowledge of modern music notation and the older style in which the Huguenot Psalter was written. This helps ensure I'm being true to the source and preserving the essential content, although a lot of change is occurring. At the end of my thesis, there will still be more transcriptions to complete. However, this initial step begins to meet a need at a scholar and layman level. This project provides composers and musicologists a new way to engage with the Huguenot Psalter, and most importantly of all, it allows performers of many different skill levels to experience the joy that comes from singing this treasured music. So walk away knowing I'm the Candyman of music. You want that rare sweet, I'll make sure you get it, especially if it's 16th century modal counterpoint. Thank you.
Thank you, Sean. This is quite interesting. I'm sure that every music nerd on the planet loves hearing about this idea.
Oh, yeah.
What, you were obviously doing work for this particular piece, but what happens when you tell your friends that love music about it? How do they react?
Well, they're like, oh, that's really interesting. And then that's about it. I think a lot of us with our fields of research, we're super jazzed about it. And then we tell someone else and like, oh, that sounds neat. So to those who are nerdy with me, they're like, oh yeah. But most of the time,
what is your music background?
So in terms of education,
like do you play an instrument? Do you sing? What is your background?
I play the piano and trumpet. I did high school choir, and then in college, I went to college originally to swim, and then I decided I wanted to be a music major, and so I left my Olympic dreams, which weren't very that bright anyways, behind me.
And then how did you stumble upon this idea to do this? What led you down this path?
Yeah, so I took a course called Modal Counterpoint, and the emphasis on it is writing in a 16th century style. So I just was really intrigued by it. And also just this music is really able to sing. So my wife and I sing it together. So there's just all these pockets of influence that let me enjoy it and actually practice it, not just let it be something that's sort of dead on the page.
Great. Well, thank you, Sean. I wish you luck. Good job. Okay. We can go on to our third presenter, which is Sam Haskell from Boise State University.
James is an A-list celebrity with fame, fortune, and an immense following on social media. Millions of people read and react to his posts and hang on to his every word during interviews. He's living the life until his character comes into question in the form of several tweets that allege that he has demonstrated problematic behavior. Overnight, he starts losing jobs, his follower count is dropping, and the public is demanding answers. James is in the process of being canceled. Cancel culture is the social media practice of shaming an individual who has violated a social norm, usually resulting in a loss of social capital, including wealth, work, and relationships. Through the research question, how do people participate in cancel culture on Twitter? This research aims to understand how cancel culture works by determining the process of canceling. I conducted a case study of Kevin Spacey's cancellation that took place in 2017 via Twitter after a BuzzFeed News article revealed sexual assault allegations against Spacey by former co-star Anthony Rapp, where Rapp was underage at the time of the assault. Hours after the article was released, the first tweet with the words "Kevin Spacey is canceled" was posted. Utilizing content analysis, a qualitative method that analyzes text to determine meaning, I collected every tweet on Twitter that contained the keywords Kevin Spacey and canceled. This resulted in almost 2,000 tweets that I then coded to determine common themes. This led to establishing the process of how a cancellation takes place on social media. First, there is a recognition of a problematic behavior, which can include a violation of a social norm. In Spacey's case, sexually assaulting a minor. This recognition takes place on social media through posts circulating and gaining attention. Second, social media users share information regarding the cancelee and their cancellation. This information, sometimes referred to as evidence or receipts, can take the form of interviews, articles, videos, and more. Social media users utilizing hashtags to categorize and sort this information often leads to trending hashtags that gain popularity and recognition, such as #CancelKevinSpacey. Third, the cancelee loses social capital. During the cancellation process, it is common for not only to cancel the cancelee, but also what they were associated with. In Spacey's case, former fans tweeted they would no longer watch his work, new or old, and called for others to do the same. This response from the public led to production companies and fellow actors refusing to work with Spacey, resulting in him being reshot in a role he already filmed and being removed from his starring role in Netflix's hit drama House of Cards. My first step when starting my research was to study the work on cancel culture completed by scholars before me. However, cancel culture has yet to be defined, nor has it been determined how it really works. The data that I have collected and the analysis I have performed will aid in building the foundation and understanding the ambiguous phenomenon that is canceling. Because as social media continues to evolve, so will cancel culture. And understanding how cancel culture functions leads to understanding how people on social media exchange information and ideas, work together, and create change, which is useful information to anyone who has an audience, no matter how big or small.
Thank you, Sam. So, you had to use that word so many times during your presentation. I was thinking, is one of your goals to cancel culture?
Trying really hard to remain unbiased as much as possible. I don't necessarily think that cancel culture is good or bad. I just think it's really interesting because we're seeing impacts that come off of social media, and I want to know more about that. So I don't necessarily have a it's good or it's bad, but I do think it's interesting.
Definitely. And I think because it woven into the current environment we're in this country right now and how social media is being used. So when you've looked at it, have you found a definition of cancel culture that seems to resonate, or you're still looking for that?
I'm still looking for a definition. I've created my own definition that I'm going to be including in my thesis, but what I'm seeing is just not any research that has been created so a definition can be really substantial. So through this work, I'm hoping to create a definition that is all-encompassing and really gives us the information that is lacking at the moment.
And then one last quick question. What was the class that sort of got you involved with this concept and idea? What you started on this path?
Well, I am a big fan of media. I was a media major in my undergrad, and I got to continue doing that in my graduate education. And it wasn't until my first year of grad school where I really just started looking into cancel culture, and I was intrigued, and it's just kind of snowballed into where we are now, and I couldn't be happier.
Great. Well, this has been fun listening to your presentation. Good luck to you.
Thank you.
Okay, here we go. Moving on. Hope I'm giving the judges enough time to think about all these great students who are doing such a great job presenting their material. So next we have Bindal Makwana, who is from Idaho State University.
Concussions, unfortunately, are a common injury in athletics. Specifically, with high school athletes, about 5 to 9% of injuries are sports-related concussions. As a whole, we're trying to find ways to improve detection of concussions and help our athletes, parents, coaches, and team physicians and athletic trainers make difficult split-second decisions in a high-stress, real-time environment on the sideline. Many symptoms of concussions are invisible to us, so we look at other ways to help us detect. Neuropsychological measures are tools that examine the brain and its behaviors or functions. Literature suggests that neuropsychological measures are able to detect changes immediately following a concussion and could be predictive of concussions moving forward. So I wondered how I could examine the utility of neuropsychological measures in practice and game settings. These tools are already available to athletics departments, and it's really cool that we can task the brain in different ways and examining functioning to see what that individual is experiencing. With the help of an interdisciplinary team, I was able to create a novel study that utilized an iPad-based neuropsychological battery called C3 Logics. We use this battery to collect sideline data in real time, so in a more naturalistic setting for all high school athletes in the region who were suspected of a head injury. I used this neuropsychological data to see how it predicted to the athlete's diagnosis, concussion or no concussion. We collected this data in 64 high school athletes and found that the reaction time and symptom checklists were significant predictors of concussion outcome. So this means that athletes with a concussion were taking longer to complete tasks and endorsing more symptoms associated with a head injury as compared to athletes who actually did not have a concussion. So in this, we were 85% correct in identifying individuals without a concussion as actually not having a concussion, and 71% accurate in identifying the athletes who had a concussion. These findings are clinically significant and may indicate that neuropsychological measures could improve diagnosis, maybe by adding these measures alongside vision, balance, and other tests conducted on the sidelines, which could be really meaningful and helpful for the entire treatment team and the athletes. Concussions present in such a unique way, and while these findings are not so large or conclusive, I feel that this is a step in the right direction to see how to implement objective neuropsychological measures in real time. Proper diagnosis leads to proper care and correct return to play and return to learn protocols. So moving forward, I hope to build upon this research and inform guidelines for youth athletics in order to increase the safety and the well-being of our athletes. Thank you.
Great, thank you. So this is a timely piece of information for me personally, because just a weekend ago, my father got a concussion skiing, downhill skiing, and we didn't have anything at our fingertips to really know for sure what was wrong with him. And so I'm wondering if you perceive this work you're doing, could it be just turned into like an app on someone's phone?
So the app that I technically used an app in this project.
Oh, you do? Okay.
Yeah, and so there are some apps out there. It's just the interpretation piece that's difficult, because if we disseminate this app to tons of people just every day, we might get a lot more false positives or, the opposite. And so I don't know that we're quite there yet.
So you need the brains behind the app to be more accurate before you're ready for that. What got you interested in this subject?
What got me interested?
Yeah.
So I actually had a head injury dancing a long time ago, and then that kind of spiraled into, well, I really like working with brains and psychology, and so kind of found this little niche between neuropsychology and sports medicine.
That's excellent. I think this is really important work, and all the schools now have all these protocols. Have you been working directly with any of the high schools and the trainers and people like that?
Yeah, so it was basically the southeastern Idaho region, so all the different high schools in that area. So I worked with, for my master's thesis, I had worked with the ISU athletes, and now I transitioned to the high schools in the area.
Great, great. This is wonderful work. Well, thank you so much. You did a great job. Good luck.
Thank you.
This is why we roar. This is why we roar. This is why we roar.
This is why we roar. is why we roar.
This is why we roar.
This is why we roar.
I love the Roar campaign. Kudos to the marketing team at Idaho State. That was great. So Evan Jones from the University of Idaho is our next presenter.
Thank you. All right, folks, let's take a trip to the grocery store and walk ourselves down the seafood aisle. We'll probably see some Atlantic salmon, and since we're in Idaho, we're definitely going to see some steelhead. We might see some catfish or some shrimp too. It's increasingly likely that a lot of this food came from fish farms, or what I'm going to call aquaculture. The world is becoming more and more reliant on aquaculture in order to produce fish for human consumption. However, this industry as a whole loses greater than $10 billion annually due to preventable diseases. And much of this fish loss occurs within the first 6 months of their lives. So the normal tools we have to prevent those diseases, something like everybody's favorite word right now, vaccines, aren't able to be easily given to those small susceptible fish. Most aquaculture vaccines are injectable, and that makes them really labor intensive, which makes them very expensive. And they're also very stressful to the fish. Now, can you imagine trying to vaccinate a 1-inch fish with a 1-inch needle? It's quite the task for both the farmer and the fish. The holy grail of vaccine technology would actually be an oral vaccine that we can just ingest. So picture yourself at the pharmacist, and instead of waiting for our COVID shot, we can just take a pill and be on our way. That's essentially what we're trying to do in fish. But current oral vaccines in fish are made with tiny vaccine particles that are coated on top of the food before feeding it to the fish. Those tiny particles are easily lost to the water, ensuring that the fish never receives the full dose of the vaccine, and they can be easily destroyed in the stomach. And the tricky part about oral vaccines is that that particle needs to make it to the intestine, and that's where it can stimulate the antibody response and the immune protection. What researchers at Oregon State University have done is develop a fish vaccine pill that's the same size as the fish food and has some added flavors to it to help the fish key in and eat it. This encapsulation technique should also provide some protection for the vaccine during its passage through the stomach into the intestine. In my research, I'm going to feed this oral vaccine pill to sablefish, a marine species, and rainbow trout, which is a freshwater species. And we're going to compare that antibody level and immune response and the protection afforded from that vaccine, from that oral vaccine, to other vaccines such as injection-based. If that oral vaccine pill can provide a similar amount of antibody response and immune protection, it will greatly reduce the costs of vaccination programs for fish farms and allow them to vaccinate those really small susceptible fish. Overall, it should increase the efficiency of fish farms greatly. And if we can do this, it will lower the production costs of those aquaculture farms, leading to lower prices of fish at the grocery store for us. Thank you.
Right under the wire. Good job. Anyway, I'm excited about this. I'm a big seafood fan, and if it lowers the cost of the food I want to eat, that's a great thing. So how much have you interacted with people in the aquaculture industry? And I think of like the Magic Valley where a lot of the trout farms are. Have you had a chance to work with any of the leaders in that side of the house?
So I've actually worked with them on finding the specific bacteria that I'm going to use to protect these fish against. But my background is actually mostly with state agencies, and that's more growing fish for recreation purposes. but it's all kind of the same good husbandry, best management practices that all of these aquaculture facilities and fish farms need to follow in order to get healthy fish out there.
So have there been any, as part of your research, have you done any scenarios where you predict how much money they might save? Or do you have to get to the point we've got the pill first?
Yeah, well, right now, so this is just kind of the proof of concept for this vaccine pill. But I mean, the cost of there are automatic vaccination machines that cost a lot of money. And then when you factor in the labor just of handling the fish and vaccinating them, it's going to be a lot of savings for producers.
Right.
So,
It seems like it.
Yeah.
Well, good luck with your work. I hope it comes to be. Thank
Me
you.
too. Thank you.
Our next presenter, we have Brian Rosenblatt from Boise State University.
As an aspiring scientist who thought they'd be a musician growing up, I believe I have a unique perspective towards my research, and I'd like to share that perspective with you now. To begin, I want you to picture a trombone and how that trombone would sound. Now, enlarge that trombone by 10 times, now 100 times, and now 1,000 times. What would this massive horn sound like? Well, acoustics tells us that an instrument of this size would produce infrasound, or sounds much lower than what humans can hear, somewhere below 20 hertz. This is exactly the case for Earth's largest horns, volcanoes. Just like how every instrument has its own unique sound, every volcano has its own characteristic sound and personality. And if we want to try to estimate when a volcano will become hazardous, we must look at what it has done in the past. For example, if you listen to enough of Mozart's sonatas, you'll have a pretty good idea of when one is coming to its end as you've gained familiarity with Mozart's musical phrasing. If we take the time to find the acoustic signature or musical phrasing of a specific volcano, we can develop better eruption time estimates for that volcano. This is the broad goal of my research. Yet, since no two volcanoes are exactly the same, this approach is best suited for a volcano that produces consistent and reliable infrasound. This leads me to the volcano we've all been looking at for the last minute and 20 seconds. This is Volcan Villarrica, a volcano in southern Chile that produces continuous infrasound and is the poster child for volcanic infrasound studies. It's your traditional conical-shaped volcano with an open crater on top and a steaming lava lake within. In March of 2015, Villarrica erupted violently for only about 18 minutes, but with lava fountains reaching heights of 1.5 kilometers into the air. Thankfully, over 3,000 people were evacuated and nobody was killed, although there was plenty of damage to the infrastructure as well as the area's booming tourism. The evolution of Villarrica leading up to this eruption was recorded with infrasound sensors used to monitor the volcano. What these sensors showed us was that the frequency of Villarrica's infrasound, or its pitch, was actually rising in the days leading up to this eruption. Essentially, as the lava lake level within the volcano rose, the effective length of the volcano became shorter and shorter. The shorter you make an instrument, the higher the instrument's pitch will be. We visited Villarrica again in 2020, but this time the activity was stable. And to our surprise, we still observed a slight wavering of Villarrica's frequency, even though its lava lake level was constant. Since the frequency changes in 2020 were not as severe as 2015, we can try to constrain the noises that Villarrica might make when it's not in an eruptive phase. This is the more specific goal of my research. In other words, we've successfully identified the general trend to Villarrica's musical phrasing and now need to find clear indicators for when these musical phrases are truly beginning. Thank you.
Thank you. So I heard in your presentation that you visited Chile.
Yes, I did.
Yeah, how many times have you made it to the site?
Only once, and we actually went right before all of this COVID stuff happened, so I lucked out.
Oh, great.
But I was able to travel to Italy the year before, a volcano called Stromboli.
Okay, so have you visited Mount St. Helens, which is, the one right here in our backyard?
Yeah, I actually have not visited it, but it is a goal of mine. I want to climb every volcano if I could.
Oh, and how many would that be? I don't think I know the number.
Depends on if we're talking about the active ones, the inactive ones. I mean, it's probably impossible, but
right, exactly. Nice. Well, you're too young to remember when Mount St. Helens blew, but I was there and experienced the blackout and everything in North Idaho, and so That's interesting that you have one so close. So how do you feel like to finish this research, you'll need to return to Chile?
No, actually, we got a really good data set from the summit, and yeah, everything's working out really well. We got everything that we needed in our one field trip out there.
Well, great. Well, thank you for sharing this with us. Quite interesting. Good luck to you.
Thank you. Thank you.
Next one up is Karina Sanchez from Idaho State University.
I'd like to draw everyone's attention to this bird here on the top left. This is a raven, and my guess is that many of you have seen this bird before. But did you know that it's one of the most intelligent animals alive, and that it has the rare ability, like us, to problem solve? This bird is currently very common in Idaho, and we get to see it all the time. But what if I told you that 50 years ago, this wasn't the case, and that ravens were barely in Idaho at all? You see, when we build things like towns, roads, and other structures, ravens are clever enough to figure out how to use those resources for survival. This picture up top shows a raven using a power line pole for its nest, which is now a pretty common occurrence that you can see, for example, when you drive along remote parts of Highway 84, just right along the roads. As a result, increases in these structures across the landscape have caused raven populations to increase as well as reproduce in more areas. Unfortunately, this has been an issue of conservation concern because ravens are very effective predators, and they are now present in areas where animals did not necessarily evolve defenses against them. So these animals are being consumed at alarmingly high rates, which hurts entire ecosystems. Wildlife managers have used a couple of strategies to reduce this effect, but they've had limited success so far. For example, lethal removal by hunting or poisoning ravens was not effective long-term within study areas because new ravens can easily take the place of exterminated ones, sometimes even at higher numbers. You see, the ravens that were exterminated likely claimed a part of that area as their territory and kept other passerby ravens out of it. And of course, there are ethical issues with killing ravens. My thesis is focused on a different approach to raven management, where, in targeted areas, I'm coating raven eggs in oil, which causes them to fail to hatch. By keeping ravens from reproducing, we are first keeping ravens from adding new members to their population, but we're also removing the caloric demand that chicks normally place on their parents. And so we expect those ravens to consume less prey compared to ravens that do have chicks to feed. So why don't we just remove these raven nests? Well, oftentimes ravens continue to care for their oiled eggs, which keeps ravens in their territory, defending it, and keeping excess ravens out. It's kind of like tricking them into helping us. One of the many species that ravens are affecting right now are greater sage-grouse, that big bird underneath the tortoise picture. Ravens consume sage-grouse eggs and cause their nests to fail, which is really hurting sage-grouse populations. So we're treating all the raven nests that we can find in our study areas with egg oiling and measuring changes in how sage-grouse nests survive. So far, results have already shown a large increase in the survival of sage-grouse nests, and that's been really exciting because at the end of all of this, we're really hoping to use these results to improve conservation strategies for ravens and all of the many species that they are taking a toll on. Thank you.
Thank you, Karina. So when you talk about the areas that you're working on with this research, what areas of the state are you conducting this research?
I'm actually conducting most of my research in north central Nevada, but so around the Great Basin, and then also in the eastern Sierra Mountains in California, which are so beautiful. So I feel really lucky to work there.
Oh, that's interesting.
Yeah.
So what led you to, why did you choose those areas?
Well, they have some sage-grouse populations that I had worked with prior to graduate school. I was working for the U.S. Geological Survey, and then that kind of turned into a partnership with an advisor at Idaho State University to do a master's. So it was nice to continue my work there.
That's great. That's great. And how long have you been doing this?
This is the second year of my master's degree, but I got to actually start working on this project a year before I started my master's degree. So I got a little bit more data, which is really nice.
Yeah, it's always interesting to see how much time you've taken on this, and you had to distill it down to 3 minutes. But
yeah.
Thanks for sharing with us, and good luck with your work.
Thank you so much.
Next we have Anil Kumar Krosuri from the University of Idaho.
Can you see me properly? Yeah, sorry.
Yes.
My research is on dye wastewater treatment using electrohydraulic plasma discharge process. In school, we all learn about three states of matter: solid, liquid, and gas. But there exists a fourth state of matter called plasma. So plasma is the first state of matter. Do you know that 99.9% of our universe is in the plasma state? For example, sun, stars, lightning, and aurora, everything is in the plasma state. Plasma is nothing but ionized gas, which consists of electrons, neutral molecules, positive and negative ions, which has a temperature range more than 15,000 degrees Fahrenheit. Because of high temperature, plasma applications in the real world is very limited. In this study, we actually developed a non-thermal plasma that can range from room temperature to few hundred degrees of Fahrenheit. So in this plasma, we can actually discharge this plasma to electrical discharge in liquid or gas phase. So when this happens, electron temperature will still be high, around 10,000 Kelvin, but the ion temperature, excitation temperature, and heavy particle temperature around the plasma will be very low. So the reactor will have very low temperature. That's why it's called as non-thermal electrohydraulic plasma discharge process. And the other unique feature of this reactor is establishing a complete plasma discharge through the conducting channel of a dielectric plate in the middle instead of between the electrodes. As you can see in the figure, we use a dielectric plate to establish a complete plasma discharge. So when the plasma discharge happens in water, both physical and chemical effects are involved immediately. Physical effects such as ultraviolet radiation, shock waves, gravitational effects, and high temperature. Chemical effects such as formation of reactive species like hydrogen peroxide, ozone, and hydroxy radicals, which helps in oxidation and reduction of organic pollutants in water. So currently, dye wastewater is one of the major problems in the world because it cannot be treated by conventional wastewater treatment plants. So in this study, we selected methylene blue as our target pollutant dye, and our results showed more than 100% degradation and mineralization rate within just 10 minutes for high concentration methylene blue dye, which was the highest among the exciting technologies in wastewater treatment. Even the energy efficiency was the best among the exciting technologies. This process can be a potential technologies that can overcome the limitation of advanced oxidation process as well as wastewater treatment plants. This can also be used for other organic pollutants such as PFAS or 1,4-dioxane. So thank you.
Thank you. So some of this stuff's a little complicated for me, but I think you got it down to the wastewater treatment plants could use this to more efficiently treat wastewater. How do you see this saving money for?
So this technology, since we did research, the energy efficiency of this technology is the best among the existing wastewater treatment plants. So here, the plasma has a very low temperature. So plasma generates a lot of reactive species. So those reactive species like hydroxy radicals, hydrogen peroxide can help break down the organic molecules or organic pollutants into inorganic pollutants like carbon dioxide and water. So that way we can easily able to clean the wastewater and we can recycle the water.
So what kind of laboratory do you need to do some of this research?
So we need some electrical engineering laboratory and also biological engineering as well as environmental, like to test wastewater samples, concentration, we need environmental engineering lab as well.
Okay. Well, we appreciate this information. I'm in the Idaho Water Center, as you know, we have a lab here.
So this technology is currently used for PFAS removal. So we are trying to break down the PFAS carbon and fluoride bond. So I think this technology will be a potential technology in future.
Great. Well, this is exciting. I wish you luck. Thank you so much. Great, that was wonderful. I actually recognized a few students in that video. That was fun to see some familiar faces in the Boise State video. So now we're moving on to our last group of students. And we will be kicking off this section with Ember Sikorsky from Boise State University.
When you hear global warming, do you think of polar bears and icebergs? What about the smoke that hangs over Boise during the wildfire season? Do you think of diminishing snowpack at Bogus leading to a shorter ski season? Or even worse, a decreasing potato yield? How can we protect both our Idaho way of life and our planet? To mitigate global warming, we need to develop carbon-free ways to generate the power that we use every day. It turns out the biggest source of carbon-free energy in the country started right here in Idaho. Picture 1 was taken in 1951 in Arco, Idaho, and it captures the first time nuclear fission was ever used to generate power. To this day, Idaho National Laboratory is the leading nuclear energy research center in the country. To get as much power as possible while maintaining safety standards unmatched by any other power source, researchers like myself are continually developing advanced nuclear fuel. Before we can use these new fuels to generate power, we do exactly the same thing we do to cars. We crash test them. Imagine for a moment that you're trying to design a new car while maintaining safety standards. You send your car in for a crash test and you get your results back. Fail. Now what? How do you improve if you don't know what went wrong? The same is true for nuclear fuel. The more information that we can get out of our crash tests, the more we know how to improve. Now, to get data out, we need sensors that can survive the crash. In nuclear energy, a crash means simulating a meltdown. This means incredibly high temperatures and irradiation. So my research focuses on developing incredibly durable temperature sensors for these safety tests. Just as we need to understand our fuel's performance, we need to understand our sensor's performance. Panel 3 shows a model I've developed to predict sensor performance knowing only the material that it's made of. The experimental performance is shown in black, and the performance predicted by my model is shown in green. Panel 4 shows an example of my model's predictive capabilities. Since it only needs to know the material, I can predict how performance may change during the crash. I've looked at several different types of material damage, and I've determined that irradiation damage in the form of technetium, shown in red, is going to have the most detrimental impact on our sensor's performance. Now we can focus our engineering efforts on mitigating this type of damage. By helping the development of these sensors, I aim for us to get as much information as possible out of our nuclear crash tests. This way, we can advance nuclear fuel, move away from fossil fuels, and hopefully preserve both Idaho and our planet.
Great, thank you, Amber. So are you working with the Idaho National Lab, anyone there as you gather your data?
Yes, I work really closely with the scientists in the high temperature test lab out at INL.
That's great. I visited that before. That's quite fascinating to see it. So what got you interested in this area of research?
Well, I used to do debate, and I would talk about developing alternative energy because we're going to run out of fossil fuels, and getting up every weekend and saying fossil fuels are going to run out was a good way to make me think, wow, we should really do something about that.
Debate got you into this, but that's not a very linear thing. So that's interesting.
No, not necessarily.
And what kind of classes did you take to get you started on understanding more about this?
Well, I started off in physics for my undergrad, and I knew I wanted to go into energy, and I found out that in a lot of institutions that's housed in the materials science department. So then I started taking a lot of material science classes.
That's great. Well, thank you so much for sharing this. I wish you luck as well.
Thank you.
Success in your research. Thanks, Amber. Okay, we're moving on to our next presentation, and that will be Kayla Yearout from the University of Idaho.
This beautiful plant, known as Brassica napus, or canola, is grown for its oilseed content. Canola is mainly used in the production of cooking oils and is the healthiest vegetable oil on the market. It's also used as a livestock feed and biofuel. Just like any other crop, canola is affected by pests and diseases every season, with one of the most devastating being blackleg. Blackleg is caused by a fungal pathogen known as Leptospira maculans and is a major constraint to the production of canola worldwide. It has the ability to infect the plant during all growth stages, causing stem cankers, which leads to extreme crop damage and millions of dollars in yield loss every season. Although blackleg has been described since the 1700s, it was only just identified in northern Idaho in 2009, making it a new disease to the region and an emerging problem to certified seed production for the Idaho oilseed industry. Other areas around the world have been able to identify the spread of Leptospira and how it interacts with its environment, otherwise known as the epidemiology of the disease. But because blackleg is new to northern Idaho, not much is known regarding how our environment contributes to the development and severity of it. Therefore, my research focuses on the biology of the pathogen and the epidemiology of this disease. One of the most effective forms of disease resistance in plants is through a mechanism known as qualitative resistance. This is a gene-for-gene interaction in which a disease-inducing gene in the pathogen will trigger a resistance response from the plant. Leptospira isolates collected from northern Idaho have been characterized to determine the frequency of these disease-inducing genes present in our region's pathogen population. And it's by knowing these frequencies, we can then determine which resistance genes in canola will provide optimal control against blackleg specific to northern Idaho. Along with genetic resistance, foliar fungicide applications are an effective means of control. However, it's important to know when these treatments will in fact be the most effective. The time of growing season when blackleg-inducing spores are produced does vary throughout the world due to environmental conditions. So it's through the use of these spore traps we are able to identify when spores are produced and when they cause initial infection, along with the weather conditions that are providing optimal disease onset. By knowing when spores are produced and when initial infection occurs, we can then determine the best time to apply fungicides. In the end, my research will contribute to developing grower guidelines for the best management practices against blackleg and canola specific to northern Idaho. Thank you.
Thank you, Kayla. I can relate. I grew up on a farm and it seemed like every day was the battle against pests and in your field. So I totally get how important this work is. So do you have a farm background? Is that what got you interested in this, or?
Yes, I do. I was raised on a farm. I was in FFA and 4-H, raised animals, and very competitive in the agronomy and field crop contests through FFA. So.
Okay, that's how you got your start. So what is your major?
My bachelor's was in crop science and horticulture, and then my master's is also in crop science.
In crop science as well. And you're focusing on North Idaho. Is that how far south and north? What are the boundaries of the crop that you're really looking at?
It's mainly in the Palouse region, but some of the research, so I have field trials in Moscow, in Genesee, and on the Camas Prairie. So it's a little bit of a stretch, but mainly the Palouse region.
Excellent. Well, I wish you lots of luck in your research, and I'm happy to know that young people are interested in doing this kind of thing.
Thank you
so much. Next, we have Luke Telfer from Boise State University.
I spent 5 years as a wildland firefighter and know firsthand how destructive fires can be. But for those of us living in the West, you don't need to have spent hot 16-hour days digging line to understand the impact. We have to deal with smoky skies making it hard to breathe, our favorite outdoor haunts turning into shells of their former selves, and in some cases, the destruction of our homes and communities. And for fires occurring in mountainous areas like those above Boise where I live, the danger doesn't end when the fire's out and the crews have gone home. You see, by removing vegetation and damaging the soil, fire makes it easier for water to move along the surface and harder for it to soak in, potentially leading to severe floods or debris flows during the next big rainstorm as the water flows and converges and builds. Just look at Montecito, California, where in 2018, post-fire mudslides destroyed hundreds of homes and killed 21 people. Some of the aftermath is shown in the photo on the right. Now, there are some things that we can do to try and prevent or at least mitigate these catastrophes, like constructing barriers or applying mulch to slow runoff and erosion. But these things can be pretty expensive and resources are limited, especially compared to the amount of land burned every year. So in order to figure out the best places to use them, we need to know a lot more about how water moves through a burned landscape. And this is a challenge because fires are messy. One place might get burned to a crisp, while another right next to it makes it through relatively untouched, resulting in complex patterns of different burn severities, with some areas acting as slip and slides and others as giant sponges. So even though we know in general that severe fire increases the risk of flooding and debris flows, it's still really hard to predict what's going to happen without understanding the role that these spatial patterns play. But how do you study this? You can't directly compare different fires because they happen in different terrain or in different years with different weather. You can try to reproduce various patterns with controlled burns, but this is only going to really work at small scales. And even then, the high burn severities that do the most damage don't really come from controllable fires. So for my research, I found a way to represent these patterns at a large scale while also keeping the location, weather, and overall severity the same. Basically, I reconstruct a watershed using satellite measurements and then use physics equations to track where the water goes from raindrop to stream flow. Then I add a fire and run the model over and over again, mixing up the burn pattern each time like a Rubik's Cube. This allows me to see how water movement changes with different configurations and whether plugging up certain points can drastically reduce runoff. Information that could help determine when and where post-fire treatments would be most effective in preventing disaster. Thank you.
Thank you. So when you're describing that, I sort of envision you as like a gamer, putting all this stuff in and playing around with it and doing everything. Is that what it's like?
You know what? You're not far off sometimes. It kind of feels that way.
What got you interested in this other than fighting fires? Did you foresee that you'd end up in this kind of research when you were doing the firefighting, or was that later?
Not exactly. Not exactly. I guess what I found was I was very interested in researching fire. But the more I was looking into it, the more I was trying to predict things. And eventually I just really got interested in modeling because that's how you're going to try to predict things. So
Right, exactly. So what classes did you take that really started forming this idea?
Oh, I think one of the best classes I took to really form this particular idea, I took a spatial ecology class that was talking about different kinds of ecological patterns and how you measure them and all these different things. And it's really, man, I need to do this with fires. Like,
well, I don't know if you were in Boise when they had the big fire that came so close to the community a few years back that they had to fight. And I just wonder if you get out in areas like that have just been burned and have a chance to see it on the front lines.
Yeah, so I did a lot in of my firefighting experiences in Nevada, and I think outside of Elko, I did a fire basically that was burning through some of the edges of Elko, and you know, it's devastating to see what happens to the communities. You know, just doing what you can, but there's not a lot you can always do with the fires.
Right. Well, I appreciate this work, and I know we all do, so thanks for sharing with us today, and good luck.
Thank you.
All right, well, last but not least is Shelby Weber from Idaho State University.
Hello, so my name is Shelby Weber, and I'm so excited to be presenting my thesis. So I want to start out by saying that up to 90% of youth involved in the criminal justice system report experiencing adversity, or ACEs, which refers to experiences of abuse, neglect, and household dysfunction in childhood, up through 18 years old. Research has shown that increased exposure to ACEs is related to negative outcomes among these youth. And specifically, we see higher rates of reoffending, which refers to being criminally charged multiple times, and substance use. And in this study, substance use refers to impairment and severity of drug and alcohol use. So how much the substance use interferes with their lives or causes distress. We know these concepts are all related, but less is known about the specific role of substance use or how it affects these pathways. So we know that ACEs are related to more negative outcomes, but we wanted to know how. What's explaining these relationships? So for this study, we examined how substance use severity changed as a result of the amount of adverse experiences in 417 youth's lifetimes, and then in turn, how substance use affected the rate of reoffending over 3 years. So consistent with previous research, we found that there was a significant indirect effect of substance use on the relation between cumulative adverse childhood experiences and subsequent reoffending. So what this means is that in this sample, youth who reported more adverse experiences, remember that's higher levels of abuse, neglect, and household dysfunction, were more likely to have higher impairment due to substance use and thus reoffend at a higher rate. This theoretically makes sense given that substances are often used as a way to manage emotional pain that comes with experiencing these traumas. And reoffending makes sense as an outcome given that substances are illegal. They're actually the second highest rate out of all offenses. So overall, these findings demonstrate the importance of assessing for experiences of adversity in childhood among juvenile offenders and treating the mental health distress that often comes with these experiences instead of turning to substances. As a result of treating these areas, it will likely decrease the rate of reoffending, which then positively benefits our communities and overall society. Thank you.
Thank you, Shelby. So what got you interested in this work?
Well, I really got interested in this work because we know that youth offend at really high rates. So like, for instance, in this sample, youth reoffended up to 24 times, and that's a lot. And I just wanted to know how these adversities in their life contributed to reoffending. And there's just not very much on research on these youth, especially over a longer time period.
And when you say youth, what is the age ranges that you're looking at?
These youth in this sample are ages from 9 to 17 years old.
Okay, so a pretty big range.
Mm-hmm.
And then what kind of classes did you take leading up, really in your undergraduate and graduate? I'm always fascinated what sends people down a path to study certain things like this, because this is a really important piece of how we take care of the less advantaged in our society.
Yeah. You're right, it really is. I took a myriad of classes, but in both psychology and then sociology. And it's really interesting because usually psychologists, which is my career path, focus more on the mental health aspect, and then sociologists or criminologists focus more on the recidivism or the criminal outcomes. And so I took a bunch of classes from both sides and then kind of married them together because I wanted to know how these things affect reoffending, mental health, everything together, since we live in this world where these things coexist and counteract.
Great. Well, I wish you lots of luck. I enjoyed your presentation, and thank you for sharing with us today.
Thank you.
All right. We got to see some highlights from all the institutions today. I want to thank the students for their efforts today. It's clear to me that everyone worked very hard to just roll out these very professional presentations and stay within the time allotted. I do not. I'm glad I'm not one of the judges. This was really impressive work, and I think the judges will be sent to a different Zoom location to do their deliberations. And so we're going to have a little bit of a break. I'm not going to talk at you during this whole time for sure, but we'd like to invite the audience to choose their favorite among the group. Do the slido.com and vote #3MT2021. It's only going to be open for a few minutes. And again, I ask that you just vote once. We keep it fair for your favorite presenter. And then also at this time, I believe Lauren Perkinson is going to lead it. If anybody has any questions or things they'd like to ask any of our students, participants today. So we'll open that up now too. The Q&A function. If you want to have any questions, and please make sure that you address them to specific people so we know who to ask. And we ask that everyone stick around with us so that you can be here for the announcement of the winners. We'll verbally announce them on this as part of this Zoom webinar. Doesn't look like we're getting any questions right off the bat. We'll keep this open here for a minute to see if anybody has decided. We can, we have some fast facts about all the institutions of higher ed that we can share for you to see on the slides here. Here we are. Little brag points. We only picked out a few from each institution. They shared a lot. They wouldn't fit on the slides that we had.
It looks like we have one question for Luke. So Luke, do you know how much worse Idaho's fire season is expected to get due to climate change?
Yeah, I don't have a specific metric to give, but I know it will be getting worse. Just the fact that as things get warmer and drier, things are more likely to burn and burn hotter. So
Natalie, you can go ahead and ask your question. So it looks like we have a question just for any or all of the participants. What do you hope to do after you complete your graduate studies? Since that's a pretty big question, I'll let you all think about it for a little bit and move on to another one. So it looks like in Slido we have a few. Thanks to Mick for pointing that out. First question to Brian. Is it a goal to track and predict volcanic eruptions through the tracking of raised pitches?
Good question. Yeah, like that's the specific goal for what we've found with the patterns of Villarrica, essentially Villarrica's musical phrasing. And hopefully we can find these patterns in other similar open vent volcanoes. But yeah, for Villarrica specifically, that's one of the goals. Thank you.
Thank you, Brian. Looks like we have a few questions for Sam as well. The first one, do you see any backlash to cancel culture, such as anti-cancel culture?
I think we already see that, and that's one of the things that I've been looking into.
my research is mostly just building the foundation because there is a lack of research on it. So kind of delving into those implications, I think that's definitely something that's possible and that we're kind of seeing. So yeah, absolutely. It just, everyone's opinion on cancel culture seems to be different, and that's why it's so intriguing.
Absolutely. And it looks like we have another question for you as well. So do you think that cancel culture is hurting the popularity of the stars that are being questioned and or called out or canceled?
I definitely do think that we're seeing severe impacts. My case study is on Kevin Spacey, and he can't get work anymore. And each cancellation is different. That's why it's so ambiguous. But absolutely, we're seeing real-time impacts that come from social media into real world. And it's incredible to see like what impacts are actually happening. Thank you so much for the questions.
Of course. We have one more question for you. Lots of people are interested in cancel culture. So another question, is it also more like guilty before proven innocent? Would you say that's the mentality around it?
So it's definitely going like where that kind of like that bias comes in of whether or not I kind of like agree or disagree. I'm like I said, I'm trying to remain like really neutral, but I definitely do think so. Like that's definitely a possibility. That is something that we see happening. I think it's delving into like it's kind of like a jury system where social media users are the ones coming up with the punishment, quote unquote, for people who violate a behavior that they don't like seeing. So I think that's definitely a possibility. Absolutely.
It looks like we have a question for Anil Kumar. How widespread is the problem with PFAS and the contamination rate?
Hello. So PFAS is contaminated in a lot of locations around the US. So currently EPA is trying to make PFAS regulations. Right now, only two exciting technologies are currently in market. One is activated carbon and the other one is ion membrane resins. So these are the two technologies that are currently being used for PFAS water treatment. But I think in future, like plasma technology can be commercialized and be used for PFAS degradation. So right now, PFAS, like the regulations for PFAS is around 20 nanogram per liter in drinking water concentration. So it's actually very low concentration. So since PFAS has potential carcinogenic effects on humans and animals, so it's the concentration limit is very low. But EPA is trying to like make an official regulation on PFAS. So they're trying to go in different phases for regulating these compounds.
Thank you. I actually have a question for Jessica Johnson. So my background is in education, and I'm really curious, have you been met with any resistance from either the schools or the districts that you worked in regarding restorative justice practices?
So I would say skepticism, not necessarily resistance. Most educators are very open-minded. They understand that there is a problem with disruptions in the classroom, and you know, this is something that definitely needs to be talked about, and it's just an ever-increasing problem. I would say skepticism in that restorative justice, or practices rather, have kind of a, I don't know how to, like a reputation maybe. People think that it's just more softer, but really if you delve into it, it's actually, I think it keeps people on the hook more than it actually lets them off, because in a typical school setting, you know, if a kid misbehaves in my classroom, I would just kick them out to the principal's office. They would get a lunch detention, and then, you know, end of story. Whereas where it's restorative justice, they have to actually, you know, face the person that they may have harmed. And that is difficult for anyone, but especially, you know, a 12 or 13-year-old, which is the age that I teach. And so I think that when other educators see other educators using it, they become a little bit more open to it, especially because more classrooms that are using restorative justice, they will find that the kids are more happy, they're more joyful, and you know, what teacher doesn't want that?
Absolutely. And what subject do you teach? I'm just curious.
Well, so I taught 6th grade my first year, but this year, in the last 3 years, I've been teaching science.
Awesome. I was a middle school science teacher, so.
Yep.
Nice. We have another question for Brian. So what is the specific frequency this volcano produces?
Cool. Good question. So it produces a very peaked 1 hertz signal, which essentially means there's 1 oscillation in its pressure signature per second. So if we know sound speed is about 350 meters per second, that tells us the wavelength of Villarrica's infrasound is 350 meters. It has a 350 meter wavelength. And then that's also confirmed by the depth of the crater itself. Acoustics tells us an open, closed instrument would produce a wavelength that's 4 times the length of its conduit. And we see that the depth of Villarrica is about 90 meters. So it confirms that resonance. Thank you.
Thank you. And we have a question for Ember as well. So Ember, do you know of what other efforts are being made in Idaho to help the climate crisis?
Wow, that's a really good question, but also really hard to answer because there's so many different ways that you can do things to work on climate. So I don't personally know what Idaho is doing, but just in general, like sustainable farming and planting trees, working on getting into alternative energy are just the things on the top of my head, but I'm sure there's some really cool stuff I just don't happen to know.
Thank you. I'm curious too, do you have a favorite renewable energy source?
Oh, that's really hard because it's like we're at the point where we should all be working together. Like, I feel like we're almost like gambling with our futures right now. And I don't want to put like all my eggs in one energy basket. I'm like, we should do all of them, like all the renewable energies.
Sounds good to me. It looks like we have one more question, also for Ember. So is it possible to adjust the response of a sensor in real time to take into account how the sensor changes over or during a given radiation exposure?
That would be really cool. And it might be possible in the future if we were able to better isolate different types of damage. So the first types of damage are, it's just at really high temperature. Maybe it starts, well, it doesn't start melting, but the grains and the crystalline structure might start changing. The big problem is that because of the radiation, the elements in your sensor will just start changing into different elements, which don't necessarily produce the same signal. So if we had a way of like constructing sensors made of those new elements and figuring out what kind of signals those give, it could be possible, but I think we would need a lot more research to try to be able to do that.
Awesome, thank you.
And I think some of you saw the slide that was talking a little bit about some of the cooperation that's happening with the institutions of higher ed. And I just wanted to just say on a much higher level, I've worked in higher ed in Idaho for almost 30 years, and President Satterley, President Green, and President Chomp are really leading a new era of collaboration and support for each other. And I think we're all going to see the results of it over time. And this event is one of them, where we get to celebrate what we're all doing, even though it's a little bit of a friendly competition. So please pay, you can note here the collaborations that are really more tied to what our graduate students are doing. We've listed on the slide here. And I'm not going to read it to you because I know you can all read, but I just wanted to do the shout out for all 3 institutions of higher ed working together. All right, do we have all of the judges back in the room? That everybody's with us so that we can conclude the program and announce the winners. Okay, not quite yet. Not quite yet. We have a few more judges we're waiting on before we announce. Sorry to make the wait more agonizing. Oh, I know what I can do. I can show you the trophy. So you can all see these cool trophies. I'm hoping you can see it. I'll hold it in front of my camera. Can you see that, Lauren? Can you see it at all?
Kind of.
I know, it's a clear crystal round glass thing that looks really cool, but it says 2021 Research in Idaho 3-minute thesis competition, and this would be the first place winner, and I'm getting my fingerprints all over it, so I'll have to clean it up for the first place winner, but and it has the 3MT thesis logo on it. Okay, all the judges are back. Okay, I need to pull up this information that I have here. So I'm going to do the winners based on the judges' collaboration, and then at the end I'll reveal the People's Choice Award. But so our third place with a $500 award goes to Karina Sanchez. Congratulations, Karina. If we could all clap and everyone could hear, we would do that. I'll clap for you. Yay. Good job, Karina.
Oh, thank you.
Congratulations. And hope you can put that to good use. And good luck at the regional competition as well. I think that each one of you go, or just the first place. I should know that. If all three place winners get to go on to the regional, or if it's just first place. Jerry McMurtry will have to answer that question at the end. But okay. Next, we'll go into second place. Drum roll, and this is a $750 prize. And that goes to Luke Telfer. I should say Amber was from Boise State University, and Luke Telfer is from Boise State University. Congratulations, Luke, for second place. And finally, we're going to move on to first place, which is the $1,000 prize. The first place goes to Ember Sikorsky, also from Boise State University. Good job. Congratulations, Ember. She's still here?
Yes, thank you.
Yes, congratulations. Okay, and then finally, I need to announce the People's Choice Award. And that was on the Slido. And I want to congratulate our People's Choice, and that is a $250 award that goes to Brian Rosenblatt.
Thank you.
Congratulations. Sorry, that was the end of our awards today. I want to have Jerry McMurtry come on and say a few things, but I just want to say, I think every single student's presentation was compelling, interesting, and so professionally done. I was impressed, and it makes me very optimistic about our future with young people taking on this kind of research. So I want to thank all of you, and I'm going to turn it over to Jerry McMurtry, the Dean of the Graduate School at the University of Idaho.
Okay, thanks, Chandra. This is the third year we've been able to have the 3-minute thesis competition. Unfortunately, we weren't able to do it in person, but I think it was a great event. And actually, it probably gave opportunities for others to attend virtually that couldn't make it to Boise for the in-person event. But after 3 years, I'm always blown away by the level of research that's being conducted at all of our 3 research institutions across the state, and the high quality and the high caliber of our students. So big round of applause to all of our students. We are very thankful that they all committed their time to this. It does take a lot of time to put these presentations together, and I appreciate the effort. I'd like to thank all of the audience members that participated. We had over 100 in the audience, and so that's a great number, certainly more than we would have had in person. So I think we are having a statewide reach here, and I appreciate the audience members logging on, asking questions, and being part of this. I want to thank the institutional presidents, and I would just echo what Chandra was saying about their dedication to the state of Idaho, our research, and our graduate education enterprise. And I really look forward to their collaborative leadership across the state. I want to thank the judges who absolutely had the hardest job possible today. I certainly wouldn't want to be in their shoes, but I do appreciate their effort and their work in selecting the winners. I have to thank our UI Boise Moscow staff and UI Boise and Moscow staff who put all this together. And so Chandra, thanks to your team, and Lauren, thanks to all the folks up in Moscow that worked hard on this, and the ITS folks. To my graduate dean peers, thank you for being part of this activity and event and competition. I've really enjoyed working with all of you, and I look forward to working even more in the future, Tammy and Adam. So, and then Chandra, thank you for being the MC. And then to the participants, I want to thank them for being part of this, giving us an insight into all the work that they're doing, the exciting research that's going on, and looking forward to the Western Regional Competition, which will be coming up in March. Now, each institution can send their winners. And so the winners from this event, from the institutions, will be able to go. And so we look forward to seeing potentially some of you win at that level. And then beyond that, there is a national competition which is put on by the Council of Graduate Schools. And so it would be fantastic to see an Idaho institution take the national title. So best of luck to everyone. And we look forward to seeing you in February of 2022.
And thank you, Jerry. I just want to say one last thing I forgot that you all told me to say. This is for the winners. The University of Idaho will be in contact with you to provide the prize money and your trophy. So don't worry, we'll make sure you get everything, even though this wasn't in person. So that was my last little thing. And thank you, everyone. Enjoy your evening. Go Bengals, go Vandals, go Broncos.